This is Jack Jackson again with a fifth of our series of 8 videos on solving right triangles. The case we're going to be looking at in this video is when we know the angle, one of the acute angles, of course the right angle, and then the hypotenuse, so the angle hypotenuse case. Notice this is a special case of the angle, here we know this angle, and a side, so it's an angle, side, but this time the angle and the side that are opposite each other are the hypotenuse and the right angle, whereas the angle opposite leg case was what we looked at in the last video in case 4. So once again, anytime we know an angle, we can find the other angle real easily in a right triangle by just subtracting from 90 degrees. So 90 degrees minus 40 degrees gives us our angle A, which is 50 degrees. Now let's take a look here. If we're looking at angle B, which is one that's given in this case, and by the way, if you've got this set up where it's angle A is given, you can either just switch just switch B and A and the letters here, but this basic setup and the way this is solved is exactly the same. So here we go. Cosine of angle B is adjacent over hypotenuse, and that would be A over C. So if you look at this, we know the we know the C, we're looking for the A, we know the B. So we're trying to solve for A. Multiply both sides by C, and we can see that A is C times the cosine of angle B. Plug in our numbers we have, so A is 12 centimeters times cosine of 40 degrees. Notice that we are in degree mode, and it's always, you may get tired of me showing you that each time, but it's very important that you get in the habit of checking that all the time. So this is just 12 times the cosine of 40 degrees, and we get that answer there, which I'm going to store as A, 9.192533317 centimeters. Similarly, the sine of angle B is opposite over hypotenuse. If we solve for B, we get B as B times sine of angle B. So to find the side B, we take our 12 hypotenuse times the sine of the angle, 40 degrees, and that will give us the other side there, B. Let's store that as at B. I'll need this in a little bit for the area. I'll need A and B, so if I have them stored, that makes it a little bit easier to not have to type all those values in again. In fact, let's go ahead and find that area now, so that it's just alpha A times alpha B, and then divide by 2, and that gives us the area of 35.4530791 square centimeters. Okay, like usual, let's have you try one, and then check it against the video here. So I'm going to give you some numbers, and then you're going to press pause, work it out, and then come back and check it. So let's change the angle to, let's see, how about 32 degrees, and let's let C be 10 centimeters. 32 degrees and 10 centimeters. Press pause now. Okay, you're back. Hopefully you've worked this. You're going to get a lot more out of this if you will work them yourselves. 32 degrees and 10 centimeters. Now, of course, one way we could check this is to draw it with our compass and straight edge and protractor and so forth. And we can then measure it to make sure things work out correctly. We can also check some things with the Pythagorean theorem once we work this out too. So here we find the other angle to be 90 degrees minus the 32, so that's 58 degrees for angle A up here. Cosine of angle B is adjacent over hypotenuse, that's A over C. Solving for A, we see A is C times cosine of B, so that's 10 times cosine of 32. So 10 times cosine of 32 degrees is 8.48 something there. And that's centimeters, and that's A. So let's store that as A. To find side B, sine of angle B is opposite over hypotenuse, that's B over C. And so solving for B, we see B is C times sine of B. So that is 10 centimeters times the sine of 32 degrees, and that is 5.2999 something centimeters. So let's store that as B, so that's side B. And to find the area, that's A times B divided by 2, 1/2 AB. 1/2 base times height, but if B is the base, A is the height. And so that's 22.4 whatever. We can also check the Pythagorean theorem. We can check to make sure that A square plus B square is the same thing as C square. And they are both 100, so that checks. So you can kind of use that as a bit of a check. Okay, one more case down, just a few more to go.